You hear the term machine learning thrown around all the time, right? It's the magic behind your streaming service recommendations, and it's helping scientists crack some of the world's biggest challenges. But how does a machine actually learn? Well, that's exactly what we're going to break down right now. So, it all boils down to this one big question. How do you teach a computer to think? Or maybe more accurately, how do you teach it to learn? See, we're not just talking about programming a computer with a bunch of strict if-then rules anymore. We're trying to give it the power to figure things out for itself. So, what is machine learning really? And, it can feel like some kind of tech magic, but it's not. It's a method, a really powerful new way of getting computers to solve problems. At its absolute core, machine learning is all about letting computers learn from data without having to be explicitly programmed for every single possibility. And that last part, that's the real game changer. Instead of a developer trying to write code for every imaginable scenario, we just feed the machine a ton of data and let it figure out the rules on its own. Well, how does it actually work? The cool thing is, the basic process is going to feel pretty familiar, because in a lot of ways, it's modeled on how we learn. Okay, so it all kicks off with input data. This is basically the computer's life experience. We feed that experience into the ML algorithm. That's the brain of the whole operation. The algorithm crunches all that data and spits out a model, which is really just the new skill it's learned. And finally, that new skill results in an output or an action. So you've got experience, which goes to the brain, which develops a skill, and that leads to an action. Simple, right? Okay, so now that we've got the basic steps, you should know there are a few different styles of learning for a machine. Let's start with the one you'll probably see the most. It's called supervised learning, and the best way to think about it, it's just like learning with a teacher. What this means is we're basically giving the computer a cheat sheet. The data we feed it is already neatly labeled with all the right answers. It's like giving a student the study guide with the answer key. The machine gets to see the question and the correct answer over and over and over again until it starts to see the connections. The best way to picture this, it's just like teaching a toddler with flashcards. You show the algorithm a picture of a cat, and you say, cat. You show it a picture of a dog, and you say, not a cat. After seeing thousands of these labeled examples, it starts to figure out the patterns on its own, the pointy ears, the whiskers, the whole deal, so it can eventually spot a cat in a photo it's never seen before. That's supervised learning. So what happens when there's no teacher, no answer key? Well, that's where our second style comes in, unsupervised learning. If the first one was a structured classroom, think of this one as being dropped into a new city and just being told to explore. And the huge difference here, the absolute key, is that the data is totally unlabeled. We just dump a whole bunch of raw information on it. No instructions, no categories, nothing. Its job is to dive into that chaos and make sense of it all by itself. The analogy here is perfect. Imagine giving a kid a giant tub of Lego bricks, all jumbled together. You don't tell them how to sort them, but what do? They start making piles, right? Maybe all the red ones go here, all the square ones go there. They find the patterns themselves. That is exactly what unsupervised learning is all about, finding those hidden groups and structures in data. All right, on to our third and final learning style, and this one is maybe the most dynamic of all, reinforcement learning. This is all about learning from the consequences of your actions, pure trial and error. The whole idea here is built on feedback. You have a computer program, sometimes called an agent, and it has one goal to achieve. Every time it takes an action, it gets feedback. If the action was good, if it got it closer to its goal, it gets a reward, a little digital pat on the back. But if it makes a bad move, it gets a penalty. You've totally done this before. It's basically the game hot or cold. You're trying to find something, you take a step, and someone yells warmer. That's your reward. You take another step, colder. That's your penalty. You learn super fast which way to go. That's reinforcement learning in a nutshell. And it's how AI has been trained to master incredibly complex games like chess and Go. Okay, so let's pull it all together. We've got learning with the teacher, learning by exploring on your own, and learning from your mistakes. Let's do a quick side-by-side to really lock this in. So check it out. First up, you've got supervised learning. You're using that nice, neat, labeled data, and your goal is to predict outcomes. That's our teacher in the classroom. Next, you have unsupervised. This is where it gets messy with unlabeled data, and the goal isn't to predict, but to discover patterns. That's our explorer. And then there's reinforcement learning. Here, the data is really just feedback, rewards and penalties, and the goal is simple: get the biggest reward possible. That's our trial and error learner. So when you boil it all down, we're teaching machines to learn in the same fundamental ways we do, with a teacher, through exploration, and by making mistakes and trying again. And that leaves us with a really big question to think about. If we're getting this good at teaching machines to learn like us, what are they eventually going to teach us?